Thanks again, Kai, for accepting to present your research on eventual consistencies in microservices to us. I don't, as usual, I'm not stealing that much time, so please start and let's have more time for questions.
Sure. Thank you very much for this opportunity. I hope you will excuse my bad English. I'll do my very best to guide you through this presentation. This is a research project that has been going on for some time. It started a couple of years ago with a question that kept coming up, and the question was, can we ensure that a microservice architecture will be transaction safe? Since we don't have transactions, but will have to depend on eventual consistency, can we ensure that the system will end up in a consistent state? And it was a question that kept coming up, and it usually came up during a teaching session with postgraduates on microservices. They clearly wanted to go for microservices, but they were not happy about leaving transactions out of the equation. So the question always came up, are we quite sure that SAGA is going to guarantee consistency? And also, of course, the question came up, well, why should we not, couldn't we just drop the idea of microservices? But then again, the gains, the promised gains of microservices is, of course, appealing to very many companies due to the promise of agility in IT development. And because one of the key factors here is independent deployability, it will enable the companies to stop having release trains and not being dependable on other teams to finish off their work before you can ship systems in the production. So it is it's very clear to the industry that there are a lot of potential in this. So they wanted to use the microservice architecture, but still there was a lot of concerns about leaving out transactions. And also a question always come up is why can't we use distributed transactions as two-phase commits and stuff like that? So that was kind of the backgrounds for this research, trying to handle this question. Can we really assure that a system will get to a state of consistency? And why is it that you cannot use two-phase commits? To answer that question, we have to look at the CAP theorem. So it has been proved that you cannot have all three of these wonderful things. You cannot both be consistent, available, and partition tolerant. And it's in the nature of microservices that they will be in the AP area. The idea is to have a high availability, and of course it is partitioning of a system into more or less into the extreme. So there's no way to get into the sweet spot of where all three are are satisfied. So we have to leave out consistency. So that leads to dealing with eventual consistency, and that leads to a discussion about SAGAs. What are the conditions for a SEGA to work? Well, it will only work if you can issue a compensating transaction. The whole idea is that when you are somewhere down the line or getting into trouble, you have to make compensating transactions on all the partial transaction that has taken place. And then again, what are the conditions for issuing a compensating transaction? When is that possible? And it's only possible if you have a reversible system. And sometimes that is not the case. Sometimes you end up with systems that are irreversible. And this is just a small example of a system that is irreversible. You cannot go back once you have cracked the egg, and you cannot go back to the state of the egg. So the real problem is how do we handle this, and what are, in a business example of this. One of the very well-known business examples is the ATM machine. The ATM machine is irreversible. Once you have handed out the money, there's really no way to make a compensating transaction. You cannot guarantee that people are going to deliver the money back once you have handed out the money. So in business situations, there will be examples of systems that will have irreversible states. So, question is how to handle this situation. How do we then get along and make a microservice architecture for a business that has those kind of irreversible states? And at some point of this research, there was this thought about where can we look for inspiration? Who in the industry might have solved this problem in some way? So it should be a business with a long history of using IT, because it is probably something that you won't think about if you are early in IT. It also should be a business with a strong consistency requirements, because it is, of course, one way to handle the situation in reversible transaction is simply to ignore it and take it as a loss in the business. So you need to look at companies that are not willing to take that approach, and also, of course, with a complex IT setup and preferable big systems that are coupled, loosely coupled. So the idea where do you go to find that kind of a system, and the idea was that that would probably be in the banking sector, where we would find this kind of a setup, and where you could gain some knowledge and get some inspiration on how to handle irreversible states and SAGAs. So the team to do this research was then set up and it was set up with Ronny Laursen, who works at a company called Bankdata. It's a large Danish company that facilitates banking systems for a lot of banks. And Ronny was at the time of the start of the product lead enterprise architect. So he knew a lot about how things were handled inside the bank. And Kai Bromose, I'm currently a teacher at UCL in Denmark. It's not UCL in London. It's we have the same abbreviation, but we're just a small college. So we started to look into this problem and try to find out if there were some patterns that could be used from the banking solution and generalize these patterns into something that could be recommended in the microservice architecture. So what did we learn from the banking analyzer of the banking system? It seems that most banking systems can actually live within a small time span of inconsistency. There's many partial systems within the bank that lives happily with a small time span inconsistency. But of course, there are some critical real-time systems where it's not possible. So in the real world, you will probably be in a situation where part of your system is perfectly happy with eventual consistency and do have the opportunity to do compensating transactions, while other parts of the system is where it's really not an option. And the one system that is mentioned here is a trading system, where it was, from the bank's perspective, really not possible to live without a real transaction system. So how do you then mix these different system requirements and get it into a system where you can utilize the ideas from microservices? And we came up with an idea of what we call dynamic consistency. So going back to the CAP theorem, we still, of course, have to apply to the CAP theorem and be aware of that we cannot have all the free guarantees in the system. But the idea that we came up with is that what if we rethink the system and take a CAP positioning? So how do we position our system in the CAP triangle? Instead of having a static view of it and saying, well, it's an AP system, and so it has to work with the eventual consistency, our idea was to think about the CAP positioning in a dynamic way. So where we will have some of the system partitioned in an AP position and other systems partitioned in CP or CA, depending on what's needed. So it's really maybe not that revolutionary what we came up with, but it is to break down a big system into smaller parts and then make a hybrid of different CAP positionings. So how do we then go along with this idea? Our approach was to think about the system from a business event perspective, and by listing the business events in the system and follow those business events down the drain of the system, and then identify which of these events was going down an irreversible transaction path, and especially focus has to be placed on exactly those events, because those are the ones that we need to move out of the AP area of the CAP theorem, and basically that means that those part of the system cannot be broken down into microservices. So it's all about establishing a handling environment for those events. So how do we handle them? But still we want to maximize the use of microservices, because we need the agility in the business. So once we have grouped all the events from a consistency perspective, that means that we will take the events that was going down a reversible path. That means those that can be implemented as a microservice architecture, and put them into one box, and then we would take the events that needed a strict consistency and put them in another box. And the idea was to use the concept of bounded context from domain-driven designs to identify the business logic that was associated with these events. So since we cannot break down those events that needs strict consistency, we had to come up with some way of handling the situation, and maybe try to keep as much agility as possible in the IT development. So at this point, we got some inspiration from Sam Newman, where he talks about modular monolith, and the idea came up to take those potential microservices that had to be in a strict consistency group and model it as a modular micro monolith. So that means that we are now trying to make small monoliths, but modular, so they still have some agility with respect to the development phase. So this slide shows the general idea, that we first start over here by grouping all the business events and defining some microservices that would handle these business events from about the context idea, and then we need to group those microservices that need strict consistency together, and then transform this into an architecture where we have the microservices that do not have these requirements. They go on and live as microservices, but then we would take the business logic from those microservices that need the strict consistency and implement it as modules in a modular micro monolith. So that's basically the research work that that we did and what we came up with. And this work that we have done, I think it's important to point out that this is the first research paper that I've done in my career. So it may not be of the standard of what you are used to see, but it definitely has some coupling to the practical world of IT practitioners. So I think that this was more or less what I have planned for the presentation, and thank you for your attention, and I'm open for questions.
Thank you for your presentation and for providing us this view on your industry-oriented project on ensuring eventual consistency in microservices. Now it's time for question. If any from the audience, just raise your hand. Yes, we have two. So we start from Claudio, who was the first raising his hand.
Hello, everybody. Thank you, Kay, for your presentation. Very nice. And if you can show the last slide, please,
Sure.
if it is possible. I didn't get the point when you say use the micro monolith. Do you intend to deploy those microservices into one single monolith, right? Or do you intend to prepare a sort of environment where they are still distributed, but in a closed environment where you can guarantee some kind of transactional requirement? It is not clear for me. What do you mean by modular micro monolith? If you can explain better.
Sure. The idea is that these modules will run within as one process. So that means that you can have a transaction scope covering all the modules.
Perfect. No. So you deploy them as a unique artifact, right?
Yes, they will be deployed as maybe as if you use Docker, it would be like one container.
Okay, perfect. Thank you very much.
Thank you. Thank you. And we now have Jesper. We are not hearing you.
Can you hear me now?
Yep.
Yeah. Hello, Kai. Thank you
Hi.
for the nice presentation. So micro monolithic would essentially be the same as part of your monolith that you identify being a macro service, because you couldn't tear down the units any further without destabilizing consistency. Is that correct?
Yes, that is perfectly correct. You could also think about it as maybe if it was an existing system you were breaking down, you would maybe use some strangling pattern to refactor some of the functions out of your existing monolith, and that the micro monolith, or that maybe there are more than one micro monolith. That's quite possible that you have a number of micro monoliths, because they will be focused on business events. So that they will be handling a business event that needs transactions. So it's not like you have one big chunk of code left over. Hopefully it will be more than one, because otherwise it will maybe not be so much micro.
That's why I used the word macro service.
Yeah.
Because somewhere in between monolith and micro.
Yeah.
Let's say macro service.
Yeah.
Yeah, but nice to hear the reference to strangulation pattern as well. I've seen that used in my current work as well, which is incidentally at Bankdata. Thank you for answering.
Yeah, you're welcome.
Thank you. So we now have Ivan.
Hi, can you hear me?
Yeah.
Yeah.
Okay, so I have a question. Since at the beginning you mentioned compensating transactions and SAGAs, and I understand that SAGAs help in what you want to do, and then you mentioned also reversibility. Now, in my understanding, and I mean I work quite a lot in this area, so they are slightly different. Since SAGAs prescribe the existence of a compensation that is somehow ad hoc, and then you compose smaller compensation to build larger compensations. While the term reversibility is used more when you can actually run the same program both backward and forward. Now, you use the term reversibility in a different sense, or having a real reversibility you think can help in this respect?
I hope I understood your question correctly, or else you must please interrupt me. I use the term of irreversible from a business perspective. For example, if you have a business where you ship goods and you have a shipping partner coming and picking up the goods, and once the goods have been picked up, you cannot reverse that transaction. It's like it has left your business, so it cannot you cannot put it back in your warehouse. So it's like if you have in economics you have invoices and credit notes. That's a common way of doing a compensating transaction. If you have issued an invoice that has to be cancelled, you do it by a credit note. But if you have a system where you cannot do credit notes, then you have a problem, because once you've issued the invoice, you kind of got stuck up with it.
And what about you can issue a credit note, but for some reason, so better when you ship goods, you can get back the goods, but you have any way to pay for the transportation, even if the goods are back to your place. So you have an approximate undoing.
Yeah, yes, you can of course have, if you leave, get out of the IT system, and maybe you could have by paying some money get your goods back or some, but it's then you go into I think having some manual processes, and of course if we take the ATM machine and you hand off money to somebody that where there was not credit to hand off money, you can take them into court and try to get your money back, but it's not guaranteed. So it is it's a thought about how can we make a safe business, safe systems.
So that's about mainly undoing the side effect, let's say.
Yeah.
Okay. Yeah, I think here the term compensating transaction is probably more fitting than reversibility.
Okay, yeah.
Okay, so it seems that we have no more question, and so I think we can thank again Kai for his presentation, and you will find everything on the YouTube, also the links to the references, and if any of you wishes to make questions, just drop us a message or a message to Kai.
Yeah, sure, I'll be happy to answer them.
Okay, thank you all, and have a nice day. See you.
Thank you, Kai. Have a wonderful day. Excellent presentation. Thank you.
Thank you very much.
Thank you very much.
Thank you. Bye.
Bye.